is an example of the mask. Okay? In the experiment, you are supposed, just one next to the other, okay? You are supposed to walk past the mask, but as it is not very easy for you to move, we are going to move for you. And I'm going to explain that with the PowerPoint, what we call the reverse mask. The reverse masks are just, the reverse masks are just a regular mask and the hollow face on which I have painted a nose, lips, and the eyes. Do you notice anything strange when I pass by you? Do they all both behave the same way? No. No. What is different?
Yeah, you notice something, sir?
Yeah, the nose is.
You notice?
But the nose here that is squeezed inside in the.
Yeah, can someone tell me that in a very smaller? That's the only thing you see. The hollow face should behave a little more strangely. When you are right in front, okay, the hollow face is normal. You don't distinguish between the hollow face and, but when you move by it, don't turn the camera. Just look at it like that. You should see that the hollow face,
In one, the surface of the face is front and another
yes,
one, the surface is inside.
the hollow face, yes, which is inside, seems to always look straight at you in the eye. You all see that?
Yeah, yes.
I first thought that it was due to the stereo vision because you have two eyes and it's a sense of depth. Close one eye and look at it the same way with just one eye closed.
Yes. One is looking straight for us, another one is.
One is always looking at you straight.
Another one is changing its position for other side also.
So do you have any idea why? Okay, let me try and explain. I was really puzzled by that. So when you look at the two faces in the box straight, they look identical. If you walk by it, or if the face walk by you, which amounts to the same thing, well, that's what you see. You have the feeling that one of the masks turned its face to be always looking at you. Why is that? Okay, for that, I have to have you do another little experiment. Put your two fingers in front of your eyes, one in front of the other. One is very close to you, the other one is much further. And you look straight at your two eyes, at your two fingers. Now slightly move, tilt your head towards the left. Which finger moves the most? The one which is closest or the one which is furthest? The closest one seems to move more. Yes, if you are doing some geometrical optics with your children, you should know that this is something well known. It's not an optical illusion.
Angle of inclination.
Yes, the angle of inclination. So when you have a finger which is very close to you, the image on your retina will move more when it moves. Whereas when it's further away, when you move your head, you don't see the moon or the sun moving. They are too far away. But when you look at a very close object, it moves much more. We are going to use that to interpret the experiment. Okay. What is important is the position of the nose with respect to the eyes. When you look at the face, you look at the eyes, and you look where the nose is. For a normal face, I have pointed out here a dotted line that goes through the nose, and for a normal face, that line is straight between the two eyes. It's normal. Okay, for a hollow face, when the hollow face is looking straight at you, same thing. The nose is right in between the two eyes when you look at it straight. What happens when you move? Well, when you move, a normal face has a nose which is closer to you. So that nose is going to move more than the eye. It's no longer in between the two eyes. Your brain sees that and he's used to it. He said that's a normal face which didn't move. I moved. It's normal that the nose is not right in between the two eyes. But for the hollow face, well, if you do the same thing for the hollow face where the nose was further behind, the nose barely moved. So it's still straight in the middle of the two eyes. And so what does your brain think? He sees a face where the nose is straight in between the two eyes. So his interpretation is, I see this face as straight in front of me. So he has a feeling that the hollow face moved to be always in front of you because he sees the nose right in the between. Your brain is not accustomed to seeing hollow faces. He has never seen that. So your brain interprets. And this is the key to a lot of optical illusions.